Hello and welcome. Today I want to talk about all about tokenizer. So like usual in here I have a model ID and here I am using a Hugging Face model. So first we import the transformers and then here we get the tokenizer from the this model ID. If you're curious about this, you can get that model in here, the Merak 7B version 1, and this is the large language model for Indonesian language. And I'm using this for my current experiment, but in this video I want to focus for the tokenizer. Okay, before I continue about the explanation for this tokenizer, let's see what is the use for the tokenizer. So you see, if we using the LLM, our input is a sentence like this, that how do you do, like this, right? But you know that the input of the model is the number, right? But this is a sentence, and how to convert this word or this or every character in here, the number is using, I already discussed about this in my previous video, be using one hot encoding. So for example, if the tokenizer that we use is for a character, then we will have 26 token, right? Like this. We will have 26, and for every character in here it will be assigned to every one hot encoding like this. So this is will be 1 0 0 0 0 until there is 25 0, and for B for example it will be 0 1 and the rest is will be 0, and for C it will be 0 0 1 and the rest will be 0, and etc. And that is how we convert from the word or sentence to the number, so we can process it to the model. And for LLM model, it will be not limited to the character. Instead, it will be in word like this. So for this and for this word, for example, it's encoded to the 0 0 0 1 0 0 0 and the rest. And for do, it will be, for example, it will be 1 0 0 0 1 0 0 and etc. and as you know the number of word or the number of word in dictionary is, for example, for the English, how many word English in dictionary, we will have this number, and it's a big number, right? All of them will be 0 except in one place like this. So instead of referencing a word to the sparse vector or sparse matrix like this, how about we refer to the position of 1 in here. So for example, the position of 1 for the word how in here is in the index 0 1 2 3, then it will be encoded in the tokenizer, it will be encoded to 3. And for do, this is, for example, the position of 1 in the index 0, it will be 0. And for you, if it in the index 25, it's 25, not 0 0 0 1 until 25. And for do, for example, it will be 4. This is just the example. And that is how tokenizer works. Okay, that is the theory. Now let's do a little practice with this simple code. Okay, let's run this. For example, we have let's just use A. And here we get the input IDS and attention mask. This attention mask is, if you read the documentation in the Hugging Face, this is the use of this is for the model in the attention mechanism. And what we want to see is in here. So here we have 1 and 263. Now, as you can see here, we only have one character. And if it according to our previous theory, this should be only one value, right? But what is 1? So 1 is actually the special token. It's beginning, so it's boss token. The boss token is beginning of sentence token. So it's character like this. This is the special token. And the other one of special token is the end of sentence. It's like this. So to prove this, let's see A, and we add the special token. So if our theory is right, we will get 1, 263 and 1 in here. So we will get 3 value. Let's run. And as you can see here, we get 1 in the end. So yeah. Now what is the value of the end of the AOS, end of sentence token? Here, let's see. It's 2. Now as you can see, the logic is because we have Indonesian language model, usually people will assume that because it's Indonesian model, if we using a word like, for example, makan in here, we will get 1 token, right? But let's see. No, we get 3 token. This is the beginning of sentence, and this is the real token. We get 2 token in here. Let's see another Indonesian word like tidur. No, we get 2 token again. How about English word? So you know, this Merak 7 billion version 1 is the derivative model from the Llama model. So the real model is the English model. So how about we using many word many? How many token we get? And as you can see here, we get 1 token. So despite this is the Indonesian model, because the base of this model is the English model, the tokenizer is not changed, and looks like we're using the original from the original tokenizer model. Here, if you want to see, just check the tokenizer.json, and we will get the here. Check the vocab. In here we will get all the dictionary, and as you can see here, the beginning of sentence of both token is 1, and here the end of sentence is 2. So here we using many, and many is 1784. Let's see. Uh, yeah, and as you can see here, this is what we get. Other than the English word, we have a Chinese character like this. This tokenization is not just a valid word or formal word. There's some yeah, some strange sentence like this. Yeah, there's some strange character like this I can see. And I think that's all. This is how this this is how the tokenizer work. So the summary is we convert from the word to the index of 1 in the sparse matrix, and then that will be inputted to the model. Depend on the tokenizer, the index in here will be different. And yeah, I think that's all. Thank you.